Okay, so today we are going to start with a new topic that is known as potential divider, or we can say that variable potential dividers, right? Because you know that normally we use a fixed battery or a fixed cell. So let's suppose if we are using a cell, so we know that the value of the voltage remains same, right? And if we
Yes,
are using a battery or any other fixed source, so the value of voltage remains same, right? But let's suppose if you observe the power supplies, right? If you observe the regulator of the fan, so in that scenario, we are able to change the value, right? There are some discrete values between which we can easily switch at any point, right?
yes,
So today we are going to talk about the same concept, potential divider. So actually, that let's suppose if we take the example of the regulator of the fan. So when you increase or decrease the speed of the fan, so actually your potential is dividing between two components, right? So that's
yes,
why when a fan is getting low voltage, so the speed of the fan will decrease, and when it is getting high voltage, so its speed will increase, right? So that is the concept. And how to make a potential divider, or what is the circuit diagram for the potential divider? So for potential divider, we can say that when two or more than two resistors are connected in series, when two resistors are connected in series, and you know that in series combination, potential difference will divide, right? In parallel combination, it will remain same. We discuss in the concept of uh, series and parallel resistors, right? So in series
yes,
combination, you know that voltage will divide across the component. So we know that in series combination, potential difference will, or the potential difference across the power source is shared, right?
yes.
This is the basic concept of potential divider. Now let's suppose if we consider our circuit diagram for this whole setup. So we can make a circuit diagram like this. Let's suppose if we are having a battery on left hand side, and we just connect a resistor. Okay, so this is our one resistor, and then we connect another resistor. So this is another resistor, right? And the remaining components in the battery, sorry, in the circuit, this will be the positive, this will be the negative sign, and some also make the sign of the battery like this. Okay.
Okay. So it's all the distance will all be the same in all these in the two.
Yes. Actually, this is also the same symbol of the battery or the source, right? So that will give you the same concept of that battery or that cell connected in the circuit, right?
Yes,
So now our main purpose is, let's suppose if we are having two values of resistors, this one will be R1, this will be R2. Now, actually, let's suppose if we are interested in finding the output voltage through R2 only, right? Not R1. Let's suppose we connect a voltmeter, our voltmeter, right? So actually, our main
yes,
purpose is to find out the output voltage through the resistor number two, that is R2, right? So we
yes.
can say that this will be our input voltage, V in, and will be the second one will be our output voltage, V out. Okay, so this is the
Okay,
reference. So now we know that if you remember that, let's suppose if we increase the length of a wire, right? So resistance will increase or decrease.
Again.
Let's suppose if we increase the length of a
Yeah,
wire,
so the
so
resistance will
resistance will
increase.
increase, right?
Yeah.
Because we know that length increases means there will be a long path or the long hindrance for the charges. And if we decrease the length, so it means that resistance will also decrease. Now, what is the main purpose of this potential divider? What is special in this potential divider? You can observe that there is a point connected in between R1 and R2, right? And still there
Yeah.
is a length between R1 and R2. So actually, we use the concept of variable in the sense potential divider will also act like a variable potential divider. We can say that. So there is also a concept of variable. Variable means that we are allowed to move between these 2 points, right? Let's suppose
Yes.
this is the extreme top point and this is the extreme bottom point, right?
Yes.
It means that our connection, this yellow one connection, is allowed to move between these length, right? So
Yes.
let's suppose if we just move this point in upward direction, right? Like we just try to move this point over here. So we will get this wire at that point, right? So you can see that your
Yes.
length is increased and you can also move that point towards the bottom over here, right? So now you can see that your length is or your height, or we can say that the distance between 2 points is actually decreased, right?
Yes. Sir.
So this is the concept of variable. When you increase the speed or decrease the speed of the fan or any component, so that is the actual working behind it, right? Okay, clear?
Yes.
Okay. So now what are the important points from the potential divider? This topic is very much important because this is also included in your AS. So that will also like the copy paste chapter of electricity in your AS, and only 20 to 30% topics are new, right?
Okay.
So basically, we know that potential difference across each component, or we can say that the potential difference across each resistor, potential difference across each resistor depends upon its resistance, right?
Interesting. Yes.
Actually, your potential difference is linked with the resistance, right? The value of the resistance.
Yeah.
Now, we just need to write how this value or how this resistance will affect the final value of the potential difference. So the very first point is resistor with larger value of resistance.
So each of this one will have different resistance. Take it on.
Yes, in this circuit, if the distance between R2 and R1, like the point that we already mentioned over here, this one. So at this
Okay.
particular time, both are equally divided, right? But let's suppose
Yeah.
if we increase the length for R2, so you know that the resistance of R2 will increase, right?
Yeah.
And the value of R1 will decrease. But let's suppose if we just move this wire downwards, so value of R2 will decrease, R1 will increase, right?
Yes.
So we just observe the value of the output voltage from R2. So that will give you the definitely concept related to R1 also, right? If your value of R2 voltage is decreasing, so it means the value of R1 is automatically increasing, right? Because in series combination,
Yeah.
voltage varies, right? So
Yes.
the resistor with largest resistance will have a greater potential difference, right?
Yes.
And vice versa. The resistor with a short resistance will have a small PD, potential difference value, right?
Yes.
Or let's suppose one more point regarding this. We increase the value, or if we increase the resistance of one resistor, we will get a greater share potential difference. Right? So this is
Yes.
also an important point related to this concept, right? So any confusion till now in this topic?
No, no, no.
Okay. Now let's move towards the other points related to the potential divider. Okay. Now in our daily life, I will show you a component that we actually use in our labs for, or we can say that as the application of potential divider, right?
Okay.
Okay, so this is the device that we used in our lab. Let's focus on this one. You can see that there is a value written on it that 50 ohms and 1.5 ampere, right? It means
Yes.
that the value or the maximum value of resistance it can produce is equals to 50 ohms, and you will get the maximum value of current is 1.5 ampere, right? Now, what
Yes.
is the purpose of this? Let's suppose if you observe that there are two terminals, right?
Yeah.
This is one and this is the second one.
Okay.
Now let's suppose if we just connect one terminal with one source or any one component and the other terminal with the other source or the other component, right? So now you
Yeah.
can see that this slider, this is the slider, right? This is free to slide.
It moved.
Yes, because you can see that there is a rod, right? And on
Okay.
this
Okay.
rod, this slider is free to move easily, right? And you can see
Yes.
that there is a metal piece or a conductor connected with the coil or the wiring wound on that rheostat, right? This
Yes.
one. You can see that this part is insulator. This is also insulator, right?
Yes, sir.
And you can easily observe that this part is also made up of insulator. So there is no conductor connected with the base, right?
Yes, sir.
So when this slider move towards left hand side, so we can say that the length on left hand side actually decrease, right?
So please what?
Let's suppose if this slider actually moves towards left hand side over this point, right?
Yeah.
So we can see that the length on the left hand side is actually decrease, this one, right?
Yes, yes.
And
Yeah.
the length on the right hand side will automatically increase, right?
Yes. Yes.
So it means that we are actually increasing the resistance for one side and we are decreasing the resistance for the second side. Okay.
Okay.
Okay. Any confusion?
No.
Okay. So actually this is the practical instrument that we used in our labs, and the name of this instrument or this apparatus is known as rheostat, right? This is
Yes.
actually a variable resistor, right? Because you observe that the value of the resistor is mentioned as 50 ohms. 50 ohms means that let's suppose if we start from left hand side, so 0, and if we just move this slider to the extreme right, so we will get maximum 50 ohms value, right? So actually
Yeah.
50 ohm value is actually divided between two components. So if we move this
We can move
slider,
this ourselves or it'll move itself.
you can move in any direction, right? Or you
Oh.
can just and slide according to your requirement, right?
Okay.
So this is the concept of rheostat, and we use the concept of potential divider. And you know that how potential divider actually works. I will also share this picture with you with the marking on it. So actually we observe that resistor with larger resistance has greater potential difference, right? It means that if we increase the length on one side, just like on the diagram, you can see that on left hand side the length is greater, right? So it means that on left
Yes.
hand side we are getting greater value of voltage as compared to the right hand side. So this is a simple concept of rheostat, right?
Yeah.
So actually this rheostat is the practical application, practical demonstration of potential divider in our labs or in practical application that we used to perform in our lab, right?
Yes.
So we can say that this is the application of it. Simple and common application is rheostat. They will not ask you about
Also,
rheostat in your
so
exam.
potential divisor is it's not like a thing. It's inside it remain.
Yes, actually, if you observe the regulator of the fan, right? So in that purpose, there is also a potentiometer device. So that device is known as potentiometer, right? That also works on the same principle of potential divider, right?
Yeah.
So this is the concept. Now, the main thing that if we want to calculate the output voltage, so what will be the formula of output voltage for potential divider, right?
Okay.
Because we know all the concepts now, we discuss all the things related to resistance and voltage, but we need a formula to calculate the final value, right?
Okay.
And you know that again in series combination current remains same and voltage will divide, so there will be only a one value of electric path to negative terminal of the circuit, right?
Yes.
So let's suppose if we want to write the formula, so your final formula will be like R is equals to, sorry, V output is equals to R2, R1 plus R2 multiply by
Okay.
input voltage, right? So this is your final formula. And why we used to write R2 on in numerator? So the concept is, let's suppose in this particular diagram, we are interested in to calculate the voltage throughout the value of or throughout the resistor of R2, right? Let's suppose
Yes.
if we connect a voltmeter with R1, right? So we need to replace this R2 with R1. So simple thing is that output voltage actually depends upon, or we can say that in the formula of output voltage we need to place the desired or the required value of resistance in numerator, right? Let's suppose we are
Yes.
connected voltmeter with R2, so we write R2 in numerator. And if we connect it with the R1, so we need to write R1 in numerator, right? So that is the simple thing. I will write it over here. Maybe you just lost the concept. So we can say that if we connect a voltmeter R1, so your new formula will be like V R1 over R1 plus R2 multiply by input voltage, right? So this is the
Yes.
concept. And the derivation of this formula is not important. So that's why I'm not going to explain the full background because that is also one part of your.
So will it in this will it come like will it ask the question to find this?
Yes, there are some questions. There are some not in detail or very much lengthy questions related to that, because you know that this is a very simple concept because we are studying for the first time. So they only ask about the basics, and the basic formula is not much very difficult, right?
Yeah.
So that's why if they ask about the question, so question is not much very difficult. You just need to identify that voltmeter is connected with which resistor. Then you need to place that resistor's value in numerator, right?
Yes.
Any confusion?
Yeah, no, no.
Okay. And now let's try to find out some more questions from worksheet, right? Because after this, from next class, we will start the concept of practical electricity, right?
Yes.
The uses of
Um,
electricity, the uses of circuit in our daily life, how we use their those components in our. So that was the new topic and the new chapter. So we will start that one from next class. So let's suppose if we talk about theory question, I will also share that incomplete question or that you are asking on WhatsApp, right? So I will also
yeah.
share that one. So you may take the reference. That is the answer you ask me. So suppose, okay, there are concepts like thermocouple, thermometer. So some concepts in your syllabus. So question or if you find anything difficult, so let me ask the question first. That is it included or not? So I'll let you know whether it's included or not.
Um,
This is question one, and this is also like the potential divider, right? But
yes.
there are because we know that resistors have fixed value, but thermistor has variable value, right?
Yes.
So one is thermistor, second is fixed resistor, right?
Yes.
We talk about this question. So figure 1.1 shows a circuit diagram containing 2000 ohm resistor of constant resistance. This is the fixed value, and we are having a thermistor. And last question is, yes, it is a
Your
detailed.
voice is lagging a lot.
Okay, just give me 1 minute. It is clear.
Yes, a bit better.
Okay. Okay, so actually in this question there is a thermistor and resistor, both are connected in series, so we can observe that potential difference will divide over here, right? So they are
Yes.
asking at one temperature the resistance of the thermistor is 1200 ohms, right? So this is the
Yes.
value of thermistor at a specific temperature. They always mentions the concept of temperature because we know that thermistor actually depends upon the temperature, right? So
Yes. Yes.
don't worry about that because sometimes they ask about temperature, sometimes they mention the value of temperature, just like the last question that you asked. So don't
Yeah.
worry about that. Actually, they give you the reference, so that will a clear
So it's
concept.
sometimes it will not be, it will be given but not be used.
Uh, because sometimes they give you the value when graph or some values are given. So you may take the reference that resistance is increasing with increasing temperature or decreasing temperature. So you may just take a reference like this. Okay.
Um,
Okay, now main question is calculate the potential difference across the 2000 ohm resistor at this temperature. So you need to calculate potential difference across 2000 ohm resistor at this temperature. So now actually we are having two values,
yeah.
1000 ohms for thermistor and 2000 ohm for resistor. And we need to find out the potential difference across 2000. resistor at this temperature. So any idea how to find the value? All values are in front of you. Take and try to solve that. How we can solve this question?
Well,
You may take the hint like this. Both are connected in series. Maybe some formula related to series will help you to find out the value. Not compulsory, but maybe there may be a chance because that is also related to the combination of resistors.
is it 2.4 multiplied by 10 power 5
2 point.
or raised to the power of 10? I mean, like 10 multiplied by yeah.
Okay, and what will be the formula that actually you use to find that one?
The potential difference it equals ITV.
V is equals to IR.
Yeah.
Okay, so you use the concept of V is equals to IR. But the problem is that both are connected in series combination. So do you think that this formula will help you to find out the value?
No.
Okay. Any other idea, any other guess?
No.
Okay. Okay, so actually, in this question, let's suppose if you want to find out the total resistance, right? So what will be
Yeah.
the value of total resistance? Let's suppose if they ask you to find out the total resistance of the
Oh,
circuit.
uh,
I'm only
2000.
it is
Like,
not compulsory that we need to use that formula. Okay. So now actually we have a main source that is equals to 12 volt, right? This is our main
yeah.
voltage. This is our input voltage, right? And now we need to split this whole voltage into 2000 and 12,000 resistors, right? So
Yeah.
actually you use the formula V is equals to IR. That was right. Okay. But the only change that we need to make in this formula is that both resistors are connected in series. So we just need to combine them before using in the formula, right? So let's suppose V is equals
Yeah.
to 12. So first we need to find out the value of electric current, right? Because electric current remains same throughout the circuit.
Yeah.
So first we are calculating the value of electric current, and your value of resistance will be equal to the sum of both resistance, 12,000 plus 2,000,
Okay.
right? So this is the
Why
formula.
isn't that you make it the current? You
Yes.
find current.
Actually, we find the current because they only ask about the value of potential difference across 2000 ohm resistor. They are not talking about the whole circuit, because for whole circuit we already have a value of 12 volt, right? But they are not asking about that, right? So we know that in series combination potential difference will divide. So for that purpose we need to find out the value of current. When we find out the value of current, so current remains same throughout the circuit, and we can just use formula again, V equals to
Yes. Yes.
IR, right? And we can just find out the voltage again, 14,000, right?
Oh, yeah.
And just divide the value, you will get the answer of current. And then again use the concept of V is equals to IR. Now R is equals to 2000, because our desired value is equals to 2000, right? So what will be your
Yeah.
final answer?
It will be One 1.7.
1.7 for electric current, right?
No, first 12 divided by
12
that
divided by
one.
14,000.
It is 8 multiplied by 5 raised to the power of 10 minus 4.
Can you please repeat again? 8 divided by.
So 8.5
Okay.
multiplied by 10 and then minus 4. That is all.
Okay. This is the value of ampere, and we need to
Yeah,
do a formula, and you will get the value of voltage.
it is 1.7.
7.
1.7.
Okay. 1.7. But this value is okay. One mistake that we made. This value is equals to 1200, right? In question they mentioned 1200, right?
Oh, yeah.
Yes.
Yes,
So
yes.
you just need to correct this value. Your working is right. Only you just need to remove 10, and it will be equal to -3, right? -3. So again, just try to find out the value. This will be equal to
This will be 3.75 multiplied by 10 raised to the power of minus 3.
3200. Sorry, 3200, right?
Yes, yes.
So what will be
Right,
your new
100.
value?
It will be 3.75 multiplied by 10 minus 2.
Three.
No, 7.5. 7.5.
Okay, just round off it and take 3.7.
Okay.
Yes.
And then
Minus
it will be 0.74.
0.74.
Yes.
Okay. So this is the method that how to calculate the value of potential difference in series combination, right? And in second
Okay.
part, they are asking about explain why the potential difference across 2000 ohm resistor increases when the temperature increases. So actually they are talking about 2000 ohm resistor increase with the temperature increases. So how it will increase?
Um,
Any idea?
no.
Okay, actually now both are interconnected, right? It means that this 2000 will got effect because of the thermistor, right? If thermistor changes the value because it depends upon the temperature. So if temperature changes, so the value of thermistor will change and it will also affect the value of the resistor, right?
Yes, sir.
So they are asking about resistor increase. So it means that if we increase the value of, or if we want to increase the value of the resistance of this resistor, so what we need to
Yeah.
do? We need to decrease the value of resistance of this resistor, right?
Yes, sir.
Thermistor. So it means that the resistance of thermistor falls if the resistance of the thermistor falls. So the value of fixed resistor
Also, it is.
will increase, right?
Yes, sir. It is.
So actually a fixed resistor is not depending upon the temperature. thermistor is depending, and that will also affect the other components in the circuit, right?